Okay, so we just built the complete joint PPF with all of the possible combinations of cars and songs that the two as a group can make. And we've discussed how they should split up the task. Next, we're going to introduce the idea of trading. So basically, we're going to compare how they would produce individually to how they would produce as a team, and whether production as a team makes more sense. I kind of gave away the answer earlier when I said we could split it up, 6 songs, and then the rest do cars, and then we can see how it goes. Obviously, that didn't turn out so hot for them. We ended up with like 3 fewer cars or something like that than we had before. So you'll see that essentially trading can be an efficient outcome most of the time, and we'll put more specificity as to when it won't and when it will. So let's work on a particular example. All right. Okay, suppose that they have some sort of quota that they need to meet. So between the two of them, they have to make 28 cars. That should be individually. They have to make 28 cars each. But after that, they just care about writing songs. Okay, so between the two of them, they have to make 56 cars. But right now, they're just working alone. Okay, so if neither person can help out the other, how many cars and songs will each person make? So let's do that on Excel. All right, so let me throw this guy up. All right, so as a reminder, Kendrick is 4 songs per day and 4 cars per day, 1 song per day. Car should be cars. I'm going to change that. All right, and Marshall was 7 per day, 7 cars per day, and 1 song per day. Okay, and they each have to make 28 cars. 28 cars each. All right. So let me move this over a little bit because I realize it's cutting off. And let me just do this bad boy here. All right. So if I'm Kendrick and I have to make 28 cars by the end of the week, how much time does that give me? How much time am I spending making cars? Right. So I need 28 cars, and I make 4 cars per day times X days, right? What is X? Divide 28 by 4, you get 7 days. So what does that leave Kendrick? It leaves him nothing. He has no time left for songs, right? So Kendrick will make 28 cars, 0 songs. Okay, what about Marshall? So Marshall needs to make 28 cars, and he makes 7 cars per day times Y days. What is Y? Y is going to be 4 days. 28 divided by 7, right? So that leaves him with 3 days left over for songs, right? And he makes 3 songs per day times 3 days. So that's, he makes 1 song per day for 3 days. Got a little ahead of myself. So that's 3 songs, okay? So Marshall will make 28 cars, 3 songs. Okay, so right now Marshall's doing a little bit better because he makes more cars per day. All right. So I'm just going to do a little thing here, a little table I'm going to develop. So let's give me some room here. And we want, so first I'm going to design working alone. And then I want working together. And I just want to label that this one is Kendrick. And this one will be Marshall. So we said working alone is 28 cars, 0 songs. And Marshall working alone was 28 cars, 3 songs. Okay, now assume that they're working together, right? And let's just assume that they're working together first. So between the two of them now, between the two of them working together, they need 56 cars and as many songs as they can get. Okay. After that, as many songs as possible. Okay. So what are we going to do? Who's going to start making the cars? Right? It should be the person with comparative advantage. And who has comparative advantage in cars? We said that Marshall had comparative advantage in cars because he makes more cars per song. He has a lower opportunity cost of cars. Okay. So Marshall starts with cars. He makes 7 cars per day for 7 days. The max number of cars he can make is 49 cars and 0 songs. So 7 cars are left. Okay. So basically Kendrick needs to make 7 cars. Kendrick needs 7 cars. 7 cars equals, he makes 4 cars per day times Z days. How many days does that leave him? So 7 divided by 4 is the number of days that he spends on cars. So we need 7 minus 7 divided by 4. That'll be the number of days on songs. Okay, so what is that? 7 minus 7 div 4. It should be 21 over 4, or 5.25. Okay, so 5.25 days on songs, and he writes 1 song per day times 5.25 days. So he writes 5.25 songs. So Kendrick does 7 cars and 5.25 songs. All right, so we said Marshall did 49 cars, 0 songs, and Kendrick does 7 cars, 5.25 songs. All right, so let's say that they get paid a little differently for songs versus cars, okay? In particular, the amount of money that they would make for making a car is about 1/5 the amount of money that they would make for making a song. If this was Kendrick and Marshall in real life, they're probably making a lot more. But let's just say that it's 5 for 1 for the sake of simplicity. So basically, they split up the work and they want to compensate each other fairly. They want to make sure that each person, gets some sort of fair outcome here, where depending on the work, they'll trade at market value for what they did. And when I say fair, that's a kind of a loaded term. It's a normative term, as we discussed in lecture 1. But basically, I'm saying that based on the actual work that they've done, because Marshall works a little bit faster than Kendrick, but based on the actual work that they've done, they're going to get paid the fair market value of the cars per song. Okay, so they're going to trade at the value of cars per song. It's just a price that they agreed on. So for every song that Marshall wrote, he's going to say, okay, I'll let you have some credit for that, but I need 5 cars to sell. Okay. Basically, they're splitting up the task. Okay, so I'm going to do one more of these little row guys here, and I'm going to call it after trade. And so let me bring this down here. And I'm going to bring this up. And I just want to kind of bold this and say working together. And I want to bold this and say working alone. And then I'm going to bold this last one and say working together after trading. Okay. So basically, they both want to end up with, oh, sorry, I already answered this. But they both want to end up with 28 cars so that they don't get fired, okay? And they want to compensate each other accordingly. So before I jump the gun, let me answer these questions. Who will make what and why? So we already established that Marshall is going to make the cars because Marshall has comparative advantage in cars. Kendrick has comparative advantage in songs, so he'll make songs. Okay. Oh, I went too fast. Okay. Pretend the last 5 seconds didn't happen. I don't feel like editing. All right. So this is the last point here, this last little guy here. So we want both of them to end up with 28 cars. Want both to end up with 28 cars so that they do not get fired. Okay? And currently, Kendrick needs 21 cars. Marshall has 21 cars to spare. That is not a coincidence. We designed that they're going to make 56 cars between them and divide them up 28 and 28, right? So Kendrick needs 21 cars. Needs 21 cars. And 5 cars per song was the agreed upon price. So Kendrick needs to give him some amount of songs for his cars, right? So basically, we need to figure out how many songs Kendrick has to give to Marshall. Okay, so if he's getting 21 cars at 5 cars per song, right? So 21. Let's do this. 21 cars at 5 cars. Sorry, divided by 5 cars. Come on. 5 cars per song. The cars will cancel because the cars are in the denominator, right? Cars divided by cars. And this will come up to the numerator. So you're going to end up with the number of songs that is equivalent to 21 cars. And we could just do that. So equals some, let's call it Y. We already used Y. Let's call it T songs. Okay. Not to be confused with T-Pain songs. Okay. So 21 divided by 5 is 4.2. So equals T. 41.2 equals T. Okay. Or sorry, 4.2 equals 2, not 41.2. So Kendrick needs to trade 4.2 songs, right? And each song is worth 5 cars, so we can do the backwards math too. So 5 times 4.2 is 21, so he's going to get back 21 cars. Or he's going to give up 21 cars. Marshall will be the recipient of the trade, so Marshall will receive 4.2 songs in exchange for 21 cars, right? It's trade, it's mutual, so they have to basically give the same amount as one person has to give what the other person's getting and vice versa. Okay, so Kendrick currently has 7 cars and 5.25 songs. Kendrick will end up with 7 plus 21 cars and 5.25 minus 4.2 songs. Or alternatively writing that, 28 cars, which is the desired target, we wanted 28, and 1.05 songs. Okay. and Marshall had 49 cars, 0 songs, he'll end up with 49 minus 21, because he's giving away 21 cars, and 0 plus 4.2 songs. Okay. Alternatively, 28 cars, again, desired, and 4.2 songs. All right. So I'm just going to represent that over here. So Kendrick is 21 short. Kendrick trades his 4.2 songs for 21 of Marshall's cars. Who gains and who loses from trade, right? So going from the no trade outcome to the trade outcome, who gains, who loses? Both of them gain. Look, Marshall had 3 songs and 28 cars. Now he's got the same number of cars, but more songs. Kendrick had 28 cars as well, and he still has 28 cars, but now he's got a song. It's the song and some change. Okay? So both of them benefited. Okay? Now what would happen if we changed the price? Wait, sorry. I want to just kind of go back a second. Both of them benefited from trade. None of them lost. Okay? Yes, it's the case that they had a different distribution here, and they want, like, Kendrick ended up with less songs, but but he got more cars, right? They traded. They agreed upon a price and they got something better. Sorry. But what do you call it? Both of them kind of wound up with less of one and more of the other, but that was like their agreed upon structured price, 5 for 1. And then, like, okay, sure, Marshall gains 1.2 songs, Kendrick gains 1.05 songs, so Marshall did better than Kendrick, but both of them did better than they had been under no trade, right? Both of them have benefited. So when I ask you who benefits, don't say Marshall, say Marshall and Kendrick, okay? Because they're both benefiting relative to their no trade outcome. Just because one benefits more doesn't mean that they're both not benefiting, okay? Yes, one relatively gains more than the other, but we're talking absolute terms here because I don't want to hear that relative stuff. That's silly to me. If both people are doing better, then they're both doing better, okay? There's no reason to bring that relative stuff in here. What would happen if we changed the price of exchange from 7 cars to 1 song, though? So let's go back to our model here. Or no, I shouldn't say model. It's not a model. But let's go back to our work. I'm just going to copy it. And I'm going to say, working together after trade, price equals 7 cars per song. And I'll specify this one. Price equals 5 cars. Oh, sorry, 5 cars per song. Okay. So both of them. So these 3 points are still correct. They both want to end up with 28 cars, so they don't get fired. Currently, Kendrick needs 21 cars. Marshall has 21 cars to spare. And I'm just going to change this here. Oops, sorry. I'm going to change this here to 7 cars per song was the agreed upon price. And then the work will follow. So it's now 7 cars per song is T, and then T will equal 3. So Kendrick now needs to trade 3 songs for 21 cars. Marshall will receive 3 songs for 21 cars. Kendrick currently has 7 cars and 5.25 songs. So he's going to wind up with the 28 cars, but he's only giving up 3 songs now. Marshall, on the other hand, will gain 3 songs instead of 4.2. So if I were to look at this, the trade, then I'm going to say P equals 5. And then I'm going to just bring this down over here. After trade, P equals 7 now. Okay, what's the final outcome? Final outcome is that Marshall's going to wind up with, 5.25 minus 3, so 2.25 songs. and Kendrick, sorry, that was Kendrick. Kendrick's going to wind up with 2.25 songs. Marshall's going to wind up with just 3 songs. All right. So if we go to the next slide, this is basically the same outcome of what I just wrote. So now Marshall has 3 songs, Kendrick has 2.25 songs. So if I ask you who benefits in this case, well, let's compare. Marshall had 3 and 28. Now he has 3 and 28. So does he benefit? No. Does he lose? No. He's the same. He's exactly the same. Kendrick, on the other hand, did benefit. He gained 2.25 songs, didn't lose any cars. Okay? So Marshall stays the same. Kendrick benefits. The reason that Marshall didn't benefit, he didn't lose, but he didn't benefit, is because the rate of exchange, the 7 cars per song, is actually exactly equal to his opportunity cost. So when it was lower than his opportunity cost, he benefited. When it's equal to his opportunity cost, he neither benefits nor loses. If it's higher than his opportunity cost, and he's the comparative advantage producer for that good, right? If it's higher than his opportunity cost, then he's not going to accept the trade at all. If the rate was 8 cars per song, he would rather just produce by himself. So he wouldn't accept the trade and he wouldn't engage in trade. Okay? So in that sense, it's not beneficial if it's higher than his opportunity cost for him to trade cars for songs. Okay, if the rate of cars per song is higher. That being said, opportunity cost and comparative advantage is reciprocal, so it does change things. But at any rate, Marshall stays the same because his opportunity cost is exactly equal to the rate of change, the rate of exchange. Okay. So what is the lowest price that each person will accept? Their opportunity cost. Anything lower, and they're not going to want to trade with that person, so they'll walk away from the deal. Okay. So Marshall will not accept anything less than 1 car for 7 songs. Kendrick will not accept anything less than 1 song for 4 cars. 4 cars for 1 song, basically. Anything more than 4 cars for 1 song, because it would be going the opposite way. Because Kendrick is getting rid of songs. That's his comparative advantage. Good. Okay. So basically, if we, and I encourage you to do this at home, if you tool around with the price, you can see why that would be the case. Okay. I'm not going to take it any further. You can do it on your own. Okay. So this last point, there exists at least one price at which 2 parties can gain from trade, provided that they have different opportunity costs. So in the example that I showed you, anything between 7 cars per song and 1/4 cars per song, or 4 songs per car. No, 4 cars. Anything between 7 cars per song and 4 cars per song was beneficial for both of them. At exactly 7 cars per song, it ceased to benefit Marshall, but he didn't lose. And at exactly 4 cars per song, it would cease to benefit Kendrick, but he wouldn't lose. Okay? So anything in between is beneficial. So as long as they have different opportunity costs, there exists some value of exchange that will benefit both of them. If both parties have the exact same opportunity costs, then basically it's as though you gave Marshall 14 days and Kendrick was never in the picture, or you gave Kendrick 14 days and Marshall was never in the picture. Because if they have the same opportunity cost, basically they have the same production pattern. Maybe one has or they have proportional production patterns. So it doesn't really make sense for them to trade, but they will be able to produce more totally. And basically their PPF will be a straight line, but just shifted out a little bit further than their individual PPF would have been, depending on how reciprocal. If it's exactly equal, then the PPF will shift out exactly double, because it's as though you gave them double the amount of resources. But at any rate, as long as they have different opportunity costs, which will be every example that I give you, there exists at least one price at which both parties can gain from trade. Okay. All right. So I'm going to give you some clarifying questions, some recaps, and then y'all can answer them on Blackboard. Don't forget homework 2. I'm going to put it up instantly. It's already ready to go. As soon as these lectures are up, by now you would have seen this on Blackboard. I'm guessing at this point you would have watched all the lectures, but you can't solve it without the lecture. So don't. All right. Have a good week, everybody. I'll see you next Monday. Yeah. All right. Bye.